Now, we've talked about the product rule when you're multiplying two things, but what happens when you're trying to divide two things? Well, there is an option where you could bring this up to the top and actually make that exponent negative. So in other words, you'd end up with x cubed plus 1 times x to the fourth plus 1, and that x to the fourth plus 1 would have a negative exponent. You could do this and actually use your product rule. The only issue is that we haven't really talked about yet how to actually work with this guy. And believe it or not, that's actually in our next section of notes. So for right now, hang on to that because we can actually show how and why it works in the next section. But for right now, we're going to go ahead and look at just specifically the quotient rule when you're trying to divide two polynomials and you're also trying to take the derivative of that division. And the quotient rule pretty much just states that anytime you have a polynomial divided by another polynomial and you're trying to take the derivative of that, then we end up then with the derivative with respect to x of f of x on top divided by g of x on the bottom is equal to the derivative with respect to x of your f function, so that would be your f of x, times your g of x function minus your f of x times the derivative of your g function. So the derivative again of g of x. So it's really similar to kind of that product rule. The only difference is here is that you actually have a minus symbol in between them. And again, this would all be over your g of x quantity squared. So that's another kind of like thing that separates product from quotient. So this is actually your quotient rule and how to actually take the derivative of that. So in all, then you'd end up with f prime of g minus g prime of f all over g squared. Now, someone once told me that when you're trying to use the quotient rule, a little kind of just saying that you could use to kind of help you out is low d high. In other words, the low stays exactly the same. D high, meaning you're taking the derivative of the high part, your f function, minus high d low, so your high function, f of x, times the derivative of your low function, g of x, all over low low. So once more, it goes low d high minus high d low all over low low. So low d high minus high d low all over low low. And so if that helps you out in remembering the quotient rule, by all means, feel free to use that. Now, how that actually translates with example 6 is we're going to go ahead and actually treat this very, very similarly to the product rule. We're going to go ahead and say that this top guy is f, this bottom guy is g. So off to the side then, we have f is equal to x cubed plus 1. G is equal to x to the fourth plus 1. Taking the derivatives of each, we end up with f prime coming out to be 3x squared. For g prime, we have it come out to be 4x cubed. Doing our cross, just like we did with product rule, we end up with, and this again is where actually the placements matter. So it was low d high, so g times the derivative of f, so that's x to the fourth plus 1 times 3x squared, minus high d low, your f function times the derivative of your g function. That's x cubed plus 1 times 4x cubed all over low low. In other words, your g function squared. So x to the fourth plus 1. And again, this would be our derivative for our function. Now you could go ahead and actually distribute these items and simplify this on top, and then maybe something we cancel on the bottom. But for right now, we're just going to go ahead and leave it alone. But again, you could do that. And again, though, that is example 6 with the quotient rule from our 2.4 set of notes.